Welcome back to this deep learning playlist. Please consider subscribing to the channel if you are new here and consider watching all the tutorials in sequence to have a better grip on the subject.
Hello everyone and welcome back to the deep learning playlist. In this lecture, we are going to talk about how to improve the performance of a neural network. Neural networks are a powerful tool for solving complex problems that we have already learned so far. But building an efficient neural network can be challenging. So what could be the methods to improve the performance of a neural network? Let's try to find out. In this lecture, I am going to show you some tips to help you improve the performance of your neural network. And the very first tip would be increasing the number of hidden layers. This could be one of the ways to improve the performance of your neural network. Hidden layers helps the network to learn more complex and abstract features from the input data. However, adding too many hidden layers can lead to overfitting as well, so it is really important to strike a balance here. The second idea is to increase the number of neurons in each layer. This could be another efficient way to improve the performance of your neural network. Increasing the number of neurons in each layer, or you can say if you allow more neurons to the network to learn more fine-grained details from the input data, then this method can become really helpful. But again, as you can already guess, you will have to consider a balance over here as well in order to avoid the risk of overfitting. Third point would be to make sure that you are using all the methods to tackle overfitting. I would not talk much around it because the previous lecture itself was around all the techniques in order to tackle overfitting. So in case you have missed that particular lecture, then please consider checking it out because we have discussed around the methods like data augmentation, early stopping, etc. In a nutshell, please make sure that you are using all the possible techniques to tackle overfitting in order to get the optimum performance from your model. The next point would be to handle issues like vanishing gradient or exploding gradient by using better weight initialization techniques. So weight initialization can have a big impact on the performance of your neural network. In general, it is a good idea to use weight initialization methods that are designed to prevent vanishing or exploding gradients. There are two popular weight initialization techniques, which is Xavier and Hay initialization. These are two tested and proven weight initialization techniques, which again comes as a functionality within the Keras library. And most of the time, these two will give you the best performance. The Xavier or Chloride initialization technique is mostly used with TANH, and in contrast, Hay initialization technique is mostly used with ReLU activation. For the time being, I am not covering these two in depth, but in case you want a dedicated lecture on these two topics, then please feel free to let me know below in the comment section, and I will definitely create a dedicated lecture around these two. But in a nutshell, when you are training a neural network, the initialization weights assigned to the model can play a crucial role in determining its performance. If the weights are too small or too large, the network may have difficulty to learn the correct patterns from the data, resulting in poor performance obviously. And the common problem that can occur is vanishing or exploding gradients, which happens when the gradient becomes either too small or too large during training respectively. And this is the reason we use these techniques, these weight initialization techniques, to start with the best possible value of the weights. Moving ahead, it is also important that you train your model for number of epochs which will help you, or you can say which will help your model for efficient learning. Doing too many epochs is also not a good idea, and this is why you will use the methods like early stopping that we have discussed previously in the lecture of tackling overfitting. So please keep this one as well into consideration. And the next point is using a suitable activation function. The activation function is another important component of a neural network. There are many activation functions to choose from, but some of the most popular ones are ReLU, Sigmoid, and TANH that we have already discussed in details within the dedicated lecture of activation function within this playlist. And over there, we have also learned that ReLU is a good choice in most of the cases, especially when you are working with hidden layers, and it tends to work well and is computationally efficient as well. For more details, please consider checking out the activation function lecture to have an end-to-end idea around activation functions if this concept is new to you. The next idea would be to use a better optimization algorithm, or you can say a better optimizer. So optimizers are responsible for updating the weights of the neural network during training. And we have already discussed this particular thing in absolute details within the part 1 and part 2 of the optimizer lecture. Some popular optimization algorithms are stochastic gradient descent, Adam optimizer, and RMS prop, etc. Choosing the right optimization algorithm can have a big impact on the performance of your neural network. The next idea is to set an appropriate learning rate. So the learning rate determines how quickly the weights of the neural network are updated during training. Setting the learning rate too high can lead to overshooting the optimal weights, while setting it too low can lead to slow convergence as well. You can experiment with different learning rates to find the one that works best for your neural network. And the next thing that you need to take care of, the batch size. So basically the batch size determines how many samples are processed at a time during training. Choosing an appropriate batch size can speed up the training process and improve generalization performance of the neural network. A larger batch size can speed up the training process but may lead to slower convergence or overfitting, while a smaller batch size may lead to more noisy gradient and slower training. So it becomes important to choose a suitable batch size here. Another thing that you can consider, that would be batch normalization actually. It is a method or algorithm that makes the training of a neural network faster and more stable. In simple words, the way we normalize the input data with the mean of 0 and standard deviation of 1 is the same transformation that will be applied to the activation function and output of hidden layers as well. And the last point that you need to understand is scaling the data. Scaling the input data can also help improving the performance of your neural network. Rescaling the data can help to ensure that each input feature contributes equally to the training process and can prevent the optimization algorithm from getting stuck in local minima. So over here we are talking about the normal scaling, like something like 0 to 1. In case the value of your feature ranges in thousands or even bigger number, in that case, please consider scaling your values for an efficient training. So as a conclusion, these are few tips to help you improve the performance of your neural network. Remember that building an efficient neural network is a complex task that requires experimentation and iterations. And with these tips in your mind, you will be well on your way to building better and more powerful neural networks. Thank you very much for watching, and be sure to subscribe to our channel for more data science tips and tutorials. I'll see you in the next video.